Okay, so hopefully you all follow the directions I've posted on LMS and you have read through section 1.3. Hopefully before you watch this video, or you at least have that PDF open and are going to kind of follow along with me while we talk through this together. I will be adding in some notes, but a lot of this is probably just going to be me recording my voice. So when we talked about our first section, we talked about how our undefined terms and definitions are kind of like our basic building blocks of geometry. And in this section, we are going to add some more things to those blocks. So if you are following along on page 10, right, in that first few paragraphs, it talks about theorems and postulates. So a postulate is a basic relationship that is assumed to be true without proof. So I'm sure you all have heard that in geometry class we do what are called proofs, where we use definitions and postulates and theorems and things to prove things to be true, right? We are using our critical thinking and logic skills to reason through why things in geometry work the way they do and why they're true. So again, a postulate is a basic relationship that's assumed to be true without proof. All right, and so most postulates are obvious truths observed in God's created order. So God made us this beautiful world. He created it for us, and then gave us the wonderful ability to learn about it and break it down and think through it. And math is just another beautiful thing that He created, and I'm really excited to get to teach you all about that. So we talked about how undefined terms were the building blocks for definitions of other terms. Postulates are kind of our building blocks for other theorems. And a theorem is a statement that is shown to be true by a proof, which is a logical progression of reasoning. All right, so we're not going to start proving theorems or anything today, but we're going to start talking through what some of them are so we get our good building blocks. So 3 things that we will eventually use to prove theorems are definitions, postulate, and theorems that we have already proven. So again, we have to prove stuff before we can use it at all, and we have to prove it before we can use it to prove other things. All right, so we are going to go ahead and jump into talking about our incidence postulates. So these postulates are really going to be our building blocks as we go in to start learning about some other theorems. So the first one I want to talk about is the expansion postulate. So we kind of touched on this topic the other day while we were going through our work. So the first part of this expansion postulate says that a line contains at least 2 points. So if I have 2 points here, right, I can draw a straight line through them. Right, I can connect those points. Right, but then even if I draw another point over here, I can still use either one of my other 2 points and draw a straight line. So basically what this says is that anytime you have 2 points that are in the same plane, you can always connect them with a straight line. So any 2 points that you draw, no matter where you draw them, you can connect them with a straight line. So that's what this part here means. So we're just going to kind of check that off our list. That check mark got a little out of hand there. There we go. All right, so a plane then contains at least 3 non-collinear points, right? So obviously we said our line has 2 points, right? And we can draw a line between those 2 points. But for something to be considered a plane, you've got to have at least another point off of that line, right? Because remember our definition of a plane or our technically definition of a plane, right, is that it's a flat surface made of points extending infinitely in 2 dimensions with no thickness. So our line is just a straight set of points. It's 1 dimension, but our plane is 2 dimensions, so we've got to have another point outside of that line in order for it to be considered a plane. Right, so there's my very poorly drawn plane. And then, so that takes care of the second part of that theorem. The last part is space, right? So we can also have lots of planes going on, so that's our very technical term of space. We're not talking outer space, right? Just space in general. So that means we've got to have 4 non-coplanar points. So we have this plane that I've already drawn here with our line and our noncollinear point, but we also have to have something outside of that plane to be considered space. All right, so our line postulate says that any 2 points in space lie in exactly one line. So it kind of sounds like the expansion postulate, but really what this one is talking about is when we have 2 points, right, there is only one way I can draw a line between these points. Right, so this is the only line I can draw that connects those 2 points. I can't draw something like this, right, because that's, oh, well, I missed the point, right? I can't draw something like that because that's not a line. The only way I can connect these 2 points is with this one line. So the line postulate means that any 2 points in space lie in exactly one line. So there's only one way we can draw the line between these 2 specific points. All right, so the plane postulate is very similar to our line postulate that we just talked about. This one says 3 noncollinear points lie in exactly one plane. So if I have 3 points, right, and then let's say our noncollinear point. So there's only one plane that can contain these 3 points, right, because they have to all be in the same plane. Right, so there's only one way that we could draw a plane to contain these 3 points. And this is where you've kind of got to think of it in more of a 3-dimensional aspect. This is usually where I would like to hold up a sheet of paper and kind of explain why there's only one plane that can hold them. But I will do that when we're back together in person for you. So just try your best to kind of mentally grasp this, right? We'll go back over them again on Monday. So if you're stressing out, don't be. It's going to be fine. Right, so this is our plane postulate. We've got 3 more to go over. All right, so the flat plane postulate is one that's a fairly kind of common sense postulate, but we still have to have postulates and definitions for these things, even though they make sense to us, and we think that this is what people are going to naturally assume, right? We need to still be able to clearly state that fact. So, if 2 points lie in a plane and not a place, all right, let's try that again. If 2 points lie in a plane, then the line containing those 2 points lies in the same plane. So, if we have 2 points in a plane, right, then the line that makes up those 2 points, or the line that we can draw between them, has to be in the same plane that the points are in, right? You can't have the points that make up a line in one plane and the line itself in another. That just doesn't work. It's all got to be in the same plane. All right, so for the line intersection postulate, this says that if 2 lines intersect, their intersection is exactly 1 point. I don't know what happened there. So if I have this line and this line, the point where they meet is exactly 1 point. It's not 2 points, it's not 3 points, it's not anything larger than that. It's one singular point that they intersect at. All right, and then our last one that we're going to go over today is our plane intersection postulate. And this one says that if 2 planes intersect, then their intersection is 1 line. Right, so you have plane Q, which I'm going to color in green. Right, and then you have plane P, which is this one here. So where they kind of go through each other, right? So you've got some kind of like green and yellow going on there. I wish I could layer my highlight, but I can't. So they intersect. So it's kind of like if you were to cut a slit in a piece of paper and like push another piece of paper through that slit, they're going to come together and form this line right here. Right, so line L. And again, we talked about that yesterday when we were working through those problems together in class, where the two planes come together and form a line. Right, kind of like the edge of a box, where those two faces come together, the corner makes sort of like a line, right? So that's what the plane intersection postulate says. I'm going to save the theorems that are on the next page for Monday, because this is, I know, a lot of information to cover. So Monday we'll go over those, and then we'll work through some of these exercises together. All right, praying for you guys. Hope you stay safe and that you are having a great weekend, and enjoy your Friday.